thank you for all the guys from SUSE to inviting me yet again. So I was with you guys in the last Supercomputing, and it's always nice to be with the SUSE guys. So I'm going to be talking about some services that we have for the Singularity container that can run on top of the OpenSUSE Cubic project right now. Okay, so a little bit of history on Singularity for those. Anyone here is using Singularity or containers? Okay, pretty much everyone. So Singularity was developed by Greg Corser, the same, okay, this is weird, the same guy that founded CentOS, but I'm here in the SUSE booth. And he designed thinking because a lot of people were asking for Docker and in multi-tenant environment, and that was a big no. So 4 years ago, he decided to take a route, and he designed Singularity thinking in Docker, but how to make it work in a HPC multi-tenant environment. Okay, so for those that know Singularity, since I would say November last year, so Supercomputing last year, we released Singularity 3.0, and it is now in 3.5, and it has been a long road here. 3.1, finally Singularity can integrate with Kubernetes. So after Singularity 3.1, you can run a full Kubernetes production cluster with Singularity as the container runtime of that Kubernetes. In 3.2, we bring out the plugin framework, multi-stage build. People were asking for this, having these huge container recipes and being able to pass information from one to another, and the cloud remote endpoints. That is what I'm going to be showing now. In 3.3, the fake root option, so you can now build images without sudo as long as your kernel support the user namespace, and the ORAS URI, so you can now push and pull images to the Azure ecosystem. So ORAS stands for Open Registry Azure, and also the CIF command group, so you can now play along with the Singularity image format from Singularity. Before that, it needed to go into a different repo to do that. 3.4, finally, we have encrypted containers. So after Singularity 3.4, you can have fully encrypted containers, and you can just assign them a password, and they are going to be encrypted at rest, in transit, and while running. So this is possible thanks to the CIF Singularity image file format that is a binary. And by being a binary, I can just sign that binary with regular encryption, and it will be running encrypted. So this is really adding more security to the Singularity ecosystem. And Singularity 3.5, released last week, redesigned the plugin framework from 3.2, and it now comes with ROCm support. So before this, we only had support for NVIDIA. Right now with Singularity, you can run NVIDIA and AMD GPUs. Okay. So Singularity, as I was saying in the history slide, it was really designed for multi-tenant environment and for HPC environment. And when I say this, is that by using Docker and the other runtimes, it's really hard to get access to a GPU, to InfiniBand, to run MPI and parallel file system jobs. With Singularity, it was designed since the beginning to be able to access all these systems and more. I see now people running Singularity for APGAs, different types of GPUs, different type of InfiniBand. So it is really designed for HPC environment. It is optimized for performance and security, but I just saw a paper yesterday in the workshops in benchmarks, and Singularity and Shifter can give users bare metal performance when running HPC jobs. And it's blocking privilege escalation, so even though that Singularity is a rootless container and it is running as the user, we added some capabilities from the user. So when you are running inside a Singularity container, you have less Linux capabilities inside the container, so this is securing more and more your environment. So this is a small, lightweight explanation of what is the Singularity image file format and why we can encrypt it, right? So we took a step on looking at the OCI layering system for images, And we decided that for HPC and for high performance environments, it was better to have a single binary file. And you can look at it as a tar file on steroids, right? And this is a single binary file that you can encrypt, you can sign, and you can move around as a Unix file, right? You can LS that file, you can move that file, you can copy that file with regular Unix commands. Yeah.
How about size of container? Because
Oh.
it's a single file, you can pack 10 of gigs into single one.
So it's a single file that is squash facet. So I can have an OpenSUSE or a Ubuntu or a CentOS container that is 20 megs.
If I don't pack my own software,
Yeah, in the workshop, and it's not an issue, right? If we're talking about HPC, in the workshop, I have seen users running 100 gigabyte containers, 200 gigabyte containers, and the format has been so optimized that it just scales. It works, right? So far, we haven't get someone with a bug because they are running a super big container. No, it just works. And this is how it looks inside. So everything that is in the black box is a binary. It's a one single binary, and we keep a global header. And Singularity is smart enough to read this global header, and the global header is telling Singularity from byte 1 to 3, you will see this. From byte 3 to 4, and so on and so on. So it is one binary, and we keep like a map of all the bytes inside that binary that will tell us what is inside that binary. And the cool part of that is that this huge block that is the file system of your container can be encrypted with regular Linux encryption tools. And by doing that, you can run your binary encrypted from rest to runtime. You can also sign this binary with Singularity sign, and then you can check it with Singularity verified. And what this is going to do is that it is going to apply a regular PGP protocol for signing binaries. So you can sign your container, and when you move around your container to another machine, you can verify the PGP keys that were used to sign that container. And this is adding extra trust and security to the Singularity environment. So this is a show of what I was telling you about the ROCm support. So this is a 3.5 feature released last week. And it's done now by Singularity run -ROCm, that is the AMD kind of the CUDA version. You can start running TensorFlow, Blender, or whatever GUI application with Singularity out of the box. And it is been proven that by doing ROCm with Singularity, you can have extra performance boost. AMD is about to release a paper on, they found 5, 10, and 15% performance boost depending on the application. So it's a really good combo doing Singularity and ROCm. So I'm going to go really fast on this. I've been getting this question a lot here in the conference. So what is the difference between the Singularity open source and the pro version? Is really looks like the SUSE support. So you can have the OpenSUSE and SUSE, right? And the main difference is that you will have the Sylabs people behind it giving you support, but it's the same feature-wise. Oops. And what I'm going to talk about now is a suite of services that you can run on top of a Kubernetes cluster, or you can use it on the cloud, or you can use it on top of the OpenSUSE Qubit project. So we have 3 new container services that are the remote builder, the container library, and the key store. The first that I'm going to talk about is key store is that when you sign a container, you want to move around those keys to then verify that container, right? And we decided to help users to move around their PGP keys by having a key store that is hosted by Sylabs, or you can host it in a Kubernetes environment. So you can use all these features in cloud.sylabs.io as a freemium package, but if you want extra support or you want to build huge images like 100 gig images and store 100 gig images, you can then run it yourself over at Kubernetes cluster. So this is a screenshot of how the library looks. So if you go to cloud.sylabs.io and you click on library, this is how a library looks. And the library is kind of, if you are familiar with the Docker Hub, but we are adding extra features to how are you storing a container. If the container is blue, like in this picture, it means that the container has been signed before storing it in the library. And we are adding a lot of tags to this. And this is my favorite one for this conference, is that we are going to be storing the container by the architecture. So if you create a container in a Power 9, ARM cluster, x86, we are going to, Singularity in the library is going to be smart enough to tell the architecture for the container, right? So you can then have the same container built for different architectures. We are going to store the container by a unique SUSE ID and the fingerprint that comes with the PGP keys. You can have release notes for your container, and you can have different tags for that same container. So this is how it looks. You can have Sylabs.io. You can also push from Docker Hub, NVIDIA Cloud, Amazon registry, pretty much every registry that respects the OCI hooks for pulling and pushing an image. You can use it from Singularity, or you can build it by a definition file and run it and build your new image with a remote builder and store it in the library. And by doing this, you can also continue doing that and submit that image anywhere in a secure fashion, right? So you can know that you are going to be running a secure container, but adding all the extra features of Singularity. And all these services run on top of a Kubernetes platform that you can deploy very easily with a Helm chart, and you can run them on top of the OpenSUSE Qubit project that is going to add extra security to your project. So if you have the OpenSUSE Qubit with your Kubernetes running, you can then start running the library, the remote builder, and the key store to have all your workflow for your containers. And questions? You can, so why we created this is that it was becoming really hard for us to store 100 gigabyte containers, so we are allowing people to do this. So this is one of the main things that took us to design this suite of services. Any questions around? No?
All right, let's give a big hand for Eduardo. Thank you very much. Thanks for coming to our booth and doing that. And let's give away some stuff now.